Hello everybody and welcome to the latest DCN Paris studio interview. I'm Sebastian Moss, Editor-in-Chief at DCD, publisher at Inforex Media, which is SDX, DCN, DCD, Yotta, Accelerator Compute. I'm joined by Julien Camiade, Director of Portfolio for Bull. Welcome.
Thank you.
Now, tragically, as much as I enjoy our events, it means I'm locked here and I don't get to see the great panel discussions. But a colleague came up to me and said, you've got to bring him on. He had a wonderful panel, so I'm really excited. For the people that don't know, Bull, HPC, AI, talk me through what your company does.
So our company does large-scale HPC AI and quantum solutions. We go from designing a motherboard all the way up to a full rack-scale solution and clusters. So we do really advanced hardware, software, and make it all this deliver, even at modular data center solutions.
So, you know, your history as HPC supercomputers, like pre-AI boom, you know, where you had to work out how to have large clusters that act as a single computer. I'm assuming a very easy lessons then on how to transport that to AI, but what's the shift?
So a lot of similarities.
Yeah.
For example, liquid cooling. We've been doing liquid cooling for 15 years. So we were one of the early adopters of liquid cooling. I think the big shift is more so easy for us to transition.
Yeah.
Okay, first one. We see the density growing. We've been doing 150 kilowatts rack for a few years now, so this is not new as well for us. What is a little bit different is all the power, reliability, power impact that you have at the rack level, and also all the much finer grained, I would say, telemetry, real-time visibility that you need now for your system. So I think this is the big difference we've seen. Anything else I would say is a smooth transition.
Right, and I guess, would you say a question of scale as well changed, where it's, you know, especially in America, 100,000 GPUs, a million GPUs is on the table, that even in the biggest summit supercomputer era, you wouldn't have got that scale.
So we didn't get to the 100,000 of GPUs, but typically we've deployed the first exascale supercomputer in Europe, so Jupiter, based in Germany at Jülich. We're also the one that's going to deliver the first AI factory in France, so Alice Rocoq system. So we're used to having big scale systems. The 100,000 GPUs is another level. That's also really what you see in the US now, probably at a little bit smaller scale in Europe. But we are definitely well positioned to deliver those systems.
The other change, I guess, is speed. You know, most of HPC is, to your point, government-backed research institutes. Very long procurement, bidding, all of that to eventually you get this single custom system out. Whereas with AI, it's like, I need 10,000 now, I need this, I need that.
Yeah, and that speed is because, well, you have a new AI chip every year now. And so if you don't do the investment right away, then it's already gone because you have the old object and there is something newer that's available. So I would say the speed of investment is different. And because the speed of investment is different, you also need to be able to deploy the system quicker, faster. And so that's why we see growing adoption of things like modular data centers or prefabricated infrastructure, because that enables you to do quicker deliveries and have really the latest hardware that is optimized.
So there's a couple areas where like AI and HPC are merging but also bifurcating. So you're seeing the one thing where some supercomputers that came before this current GPU wave are adding like a GPU cluster to the side, calling it like an AI addition, and they're working together. Is that something you're playing in?
So definitely. We see, so the role of AI, I would say, in HPC is to accelerate the simulation workloads that we're running. We also see that kind of things for quantum, typically. So part of the code that we run can be really optimized for this with those technologies. So that's why we're using it for in the HPC world, I would say. And then you have those more new pure AI systems where those are specific workloads with specific needs. And as I said, we're well positioned to run into this because there's a lot of similarities and a few tweaks that we need to make to be relevant.
So, but the area where they might be diverging is precision, right? Traditional HPC is very high precision.
Simulation. FP64.
Yeah, exactly, FP64. AI FP4, trying to do FP2, which, I don't want to put our viewers off, but like, it's a very different, and the money that is coming in is for AI, so the chip designs are prioritizing lower precision. Does that mean HPC gets ignored? How, yeah.
So first, you need the high precision in HPC because you do simulation like for your aeroplane. So you want to make sure that it's going to fly, precise, right? And it's precise. So this is why for those type of simulation, FP64 is still needed. But for others and more AI type workloads, you can go down in terms of precision. And here the idea is you get more speed, okay, and less precision, and you're okay with that.
Yeah.
Okay. So it depends on really the use case that you have. So the two worlds have to live together.
Yeah.
Obviously, as you said today, a lot more investment in AI. The chip makers are more focusing on AI. So on the HPC world, there are a lot of things that are moving. Could we do on certain applications with less precision?
Yeah.
That's something that people are looking at. Chip makers cannot avoid doing chips for HPC because it's a lot of businesses and a lot of things run on HPC simulation. Yeah. So this will still be there. It's just that I think the new chips will come to market in HPC maybe every 2 years, whereas for the AI it will come every year and it will be a quicker speed.
And then the other area where I assume there's some impact, AI is facing as well, but because of the voracious demand, memories in short supply, again, the AI guys can afford to spend more, right? They think, they haven't necessarily made the business model yet, but they think there's this pot of gold at the end. HPC, government contract, there's the supercomputers this much, that's all we got.
Yeah, HPC world works with RFPs, and that's month or a year and a half process. And definitely it's a different speed with AI. AI, we're talking, I want it now and I have the money to invest. So it's different. We see the huge impact of the memory.
Yeah.
So availability and everything is more focused towards the AI chips with HBM than traditional DIMMs available. So that impacts us. But so we're really focusing on this, try to improve the supply chain, make some stock so that we can deliver to our customers. But it's definitely an issue that we're dealing with right now.
Is that where being vertically integrated helps? Because I assume you know the supply chain a bit better than someone that's just at the very end. It's just procuring the final bit.
Correct. So we can anticipate a little bit things. We can try to optimize with, let's say, certain capacities that we might have instead of others. So this is all the work that we're trying to do to make sure that we have some supply on a few things and we can optimize for those few things.
So like you said, you're kind of integrated motherboard and up, right? Europe has put a lot of money into trying to build its own chip ecosystem. We have ARM in the UK/Japan, depending on how you look at it, but beyond that, it's NVIDIA's world at the moment, AMD, Intel. Do you see a future where there is a European player in that space that's actually making an impact?
So we see definitely, so on the training side, that's a world that is dominated by NVIDIA. AMD is trying to play. I think the big opening now is the inference world. And so we're definitely, as a company, Bull company, we're definitely trying to help the ecosystem in Europe to come up. And we have multiple AI accelerators specifically for inference that are coming up. And one of the goals that we have is to help them get to the market, get into the hands of our customers. So people like Accelerator, Visora, for example, and a few others. So those typically we're collaborating with them and trying to make sure that we have a European player that is visible and available on the market.
So one of the popular ways new chip companies try and get some momentum and trust in the market is setting up test beds. If they have enough money, they'll set up their own cloud. Others have just. Is that something you could see yourself becoming the kind of central point where you have a system that has a bunch of different chip makers where people can test?
So typically, because we've been designing and doing our own system, and we've been doing everything is in-house. So all the power, all the cooling is designed in-house. So right now the avenue is we collaborate with them because we help them design a cooling solution integrating into servers. Those are a lot of things that when you're moving from a PCIe form factor to more chips that you need to embed on motherboards and so forth, this is a different world.
Yeah.
So we're helping them making that transition, trying to help them get into the servers and be optimized at the rack scale solution as well. So things like what's the interconnect behind that you put. We have our own interconnect, and we can also provide some recommendations. So we're trying to help them to navigate a little bit and to make sure that they reach the end goal.
So speaking of new platforms and new paradigms, part of your portfolio is quantum. I've been in this job a decade now. I remember 10 years ago being told, give it 10 years. And it always feels forever on the cusp. Is that an unfair view? How do you see quantum?
So I think it depends on what we're talking about.
Yeah.
If we're talking about having a quantum computer that's going to do everything, it's very far. Today, what we see on the HPC world, because what we do is really simulation. Okay, AI, we're using it to accelerate part of the codes that we run, the simulation. Quantum is the same thing. So we can use quantum technologies to accelerate the simulation run that we do. We've been the first one on the market to come up with an appliance at the time. It's a few years back, where you had a traditional, I would say, hardware server. It would be a scale-up in-memory server, and we would have a software run on top of it as an appliance. And this would help researchers to start working on codes, right? And algorithms for quantum. So our role now is to focus on this, to help researchers come up with algorithms, develop that ecosystem, and then collaborate more with quantum computer vendors. People like IQM, for example, okay, or Alice and Bob. Those people, we have a big ecosystem in France and in Europe for quantum. So the idea is right now there are a lot of players. Obviously at some point that's going to consolidate a little bit. But the idea is that we accompany all the researchers to work on the algorithm, and the day there are quantum computers really available, we can help them get into it and integrate that into HPC clusters, into the data centers of our customers.
So you kind of see a world where a HPC cluster is traditional HPC with an AI aspect and with a quantum aspect,
correct,
and then maybe something else in the future.
Yeah, the future is definitely hybrid, I would say. Really, silo the ecosystem is not going to work, so I think the future is going to be systems that are hybrid with a traditional HPC code that runs simulations, but also AI and quantum. And when you see all the investments that are going on, right, we might not be able to have big investments like we did for the Jupiter system in Europe, because that's European investment, for a next big HPC system, and for a next gigafactory, and for a next quantum computer. So at some point, I think we'll be forced to combine and from the investment perspective, but also from the workloads and what we can use, because the systems are going to cost a lot of money, and it needs to be efficient and sustainable. So we need to be able to run different hybrid workloads.
Right. And your future could also be hybrid, because you can watch a video, or you can read a DCD article, you can listen to a podcast, come to one of our events. Thank you so much for the time.
Thank you for having me.
Really appreciate it. Thank you for watching.